Hello, aspiring developers. Welcome back to today's session. Today we are going to tackle more on objects. We learned about creating objects in the previous video, but now we are going to learn how to create complex objects. These we are going to achieve using the class keyword. We're going to create objects using instance of classes. Then we're also going to learn about the constructor method, the super method, how an object can inherit or borrow from a parent object. So if that sounds interesting, let's dive right in. In the previous video, we learned how to create objects, how to iterate objects, how to destructure objects, how to loop over objects, how to copy objects using the spread operator and the dot assign. So now today we are going to learn more about creating complex objects using the class keyword. So today we are going to learn the class keyword. And you notice that I only have codes for the object that we created in the previous video. So it's only one object because I want to at least narrow this down so we can tackle more and you understand better. So the class keyword was introduced by the ES6 standardization. So it provides a more structured way to create constructor functions. So we can create objects using constructor functions. We learned this when we were learning about objects. So you can go and watch the video on objects, JavaScript objects. You'll see how to create objects using the constructor function. So now, these constructor functions help us to define the blueprint, or rather the structure of creating our objects. So let us look at the class syntax on our Visual Studio Code. So we said a class is like a blueprint for the object. Before a building is constructed, you first start with the blueprint. So that defines the structure. So here you can say class person. We are now creating this one creates a person object. I want to mimic this user object, but now using a class keyword and constructor method. So the class keyword will define that class. So person has been defined as a class. Then now we pass in the constructor method. So the constructor method, this is also kind of a keyword or a special method. Here you can also pass in the name. I see we have their name, age. We also have height. You can also pass in the weight. Yeah, you can pass in those for now. And now the constructor method is the one that defines that object that we are building, or rather we are creating. As we said, it defines the blueprint. So for you to access, or rather to bind the values of the object to the constructor, you use the this keyword. You already know that this helps us to access the property of the current object that we are talking about. So if we want to access this property, then we have to call the this function on them. So I'll just paste them all here, and then here I'm going to say that this dot name, and we can equate this to a name variable. Then same to age, we are also going to say this dot age, and we equate this to the age variable. Then for the height, we'll also say this dot height, and we equate it to a height variable. Same to the weight, we equate it, yeah. Same to the weight, you're also going to say this dot weight, and we assign it to a weight variable. The assignment is missing here. Yeah, so you see that we have all this. We have the this keyword. Visual Studio Code has just added some parentheses there that I don't need. So I'll just start by removing this. And it should end in semicolon. That is why Visual Studio Code was adding all these funny curly braces. Parentheses. It should end in semicolon. and I'll also remove this parenthesis here. So this is how to access the this one initializes. So first we'll start with the class keyword, and we've said that the class keyword defines that class. So we have already defined a class person, and this class person needs a structure. So the structure is defined with the constructor method. The constructor method defines the age, the height, and the weight of the person class that has been defined. So now that this has already been defined, we need to bind it to the object, the object or the class person. So we use the this keyword to bind the name the name property of the constructor to the person class or the person object. And this here we already have our class person structure defined. This is on property. Now we can also think of how to add the calculate BMI method. You can also come and say just after the constructor. After the constructor, you can come and add the calculate BMI method, and this method will return, can just return the exact same thing that was returning up here. So we can have this code here. You see that calculate BMI, then we define a variable BMI which takes this dot user height and multiplies that by 2, and then it divides that by this dot user weight, then it returns the result, which is the BMI in our case. So here we already have an object, we have a class person, and this class person, as we said, classes define the structure or the blueprint of that object. So now if you need to create any object, you can now call the class keyword, the initialized class, so that you can instantiate an object of that class. So let's look at how to instantiate an object based on the class using the new keyword. So here you can come and say now const, can say we want to define a person. Okay, I am a person, so I can say const Georges. Yeah, and I can say const Georges equal new keyword, then the object that you have created. But you know perfectly well that this object has a constructor which defines its structure. So I have to pass in the name, the age, the height, and the weight. So if I don't pass anything, then Georges will return an empty object. So just log to the console the value of Georges at this point first. So if I run this script, I hope it is the only thing I'm logging to the console. Yeah. If I run this script, you see that Georges has that structure of the person class, but everything within it is undefined. That is because we've initialized it as an empty person, and we know perfectly well that person takes 4 parameters. That is the name, age, height, and weight. So the order in which you pass them is also is key, because you have to start with the first one that was passed. In our case, it was the name. So if you only pass that, when you rerun the script, you'll only see that only the name has been passed. So after that, you can pass in the age. You can now pass in the height. What is the height of Georges? He's about 2.5, and his weight is about 20 kg. Yeah. So this is now our object. We have created an object from the class person, or rather we can say we have instantiated an object from the class person. So if you now run the script, you see that the object has been populated with all that data. The Georges has been assigned to the name, then 10 has been assigned to the age, 2.5 has been assigned to the height, and 20 has been assigned to the weight. So that is for the property. If you want to also add the method, or rather these extra methods that we have, you now call that method using the Georges class. Actually, instead of calculate BMI, you can simply pass something like calculate here. So the time of this video is 20. We are currently in 2024, and we can return the year being 2024 minus user.age. So you can say this dot age, and we can log this to the console whenever this function has been called. So you can say log to console the value of this dot age. Yeah, so this is how to pass in methods. I'm trying to avoid that repetition of the exact same name. It will cause some error when you have that same method. So if we need to calculate the year, okay, you can say calculate birth year. Yeah, so we want to calculate the birth year of the person, that is the person that we constructed using the class, the person class keyword. So there we are going to log to the console the value of the current year, which is 2024, then minus this dot. We're going to pass in minus this dot age. So we can say pass the whole of this into into template literals and say born in. Then now we pass all this into brackets so that we can get the computed value of this. We see that this guy here was born, this guy is 10 years, so this should take 2024 minus this dot age, which is 10, and then it should output the value of 2014. So let's now try and call the calculate birth year method of the person class. So simply we're going to say Georges dot calculate birth year. So if we run the script, you're going to see that I was born in 2014. So that one calculates the birth year. Yeah, so that is how to access methods in a class. You can also add several other methods if you want. Just add them in the person class and you simply call them using the dot notation. But you may ask yourself, why should you go through the hassle of using constructors to create a function? You notice that if you try and create a new user, it will be a bit difficult for you to start modifying these values. You see, it comes with predefined values, such that if you forget to pass a value, then it will pick a predefined value instead of warning you that you forgot to add a value. But for this person, it will leave it as undefined, so that in case you forget, then you can simply see it from your terminal and then add that factor in that bit of code. And it is also very easy to create another user. So we can say here create gen, and we say gen equals to new person, and all we need person, and all we need to pass is the name of gen there, gen. This gen is about 15. The height of gen is 1.9, and the weight of gen is 60. Yeah, so here you can also log to the console the value of gen, the value of the object gen. Same, you can also call the date of birth. You can calculate the year of birth for gen. So if you run this on the console, you see that it outputs. Did we calculate the year of birth? Gen.calculate birth year. Okay, sorry, I need to pass in that, and I also have to, let me just do this so it can be a bit more understandable, it does not confuse us. So if we run this script, you notice that we have this person created, the name is Georges, the age is that, there is the height and the weight, and you see the guy was born in 2014. Then you have this person gen, with the age of 15, height of 1.9. You see the weight property there, and she was born in 2009. So you see that you can easily compute all this and achieve the values of all this with just a single line of code. So that is the benefits of using classes. You see that classes, they help us to create new objects easily. Yeah, so now can now look at some functionality using objects that are defined using classes. One of them being inheritance. Inheritance is a fundamental concept in object-oriented programming. I'll be denoting it as OOP. It allows us to create a new class, which is called a subclass or a child class based on an existing class, which can be referred to as a parent class or a super class. So the child class will inherit all the properties and methods from the super class. The same way here, you remember we were using the spread operator to inherit the values of that previous class. So here we were inheriting not user. Can say let child. Should we use child? Can say let child user equals, and then here we are passing the user object using the spread operator. So in this point, the child user was taking inheriting all the values and keys of the user object. So now let's see how we can achieve the same thing known as inheritance from our class. You see that our class does not have any values, but instead it has a constructor to just build the structure. So let's see how we can inherit this structure from our child class. So we have here a person class, which is in this case our parent class. So now for us to inherit all those values, as I said earlier, we have to create another class that will also have these properties. So we can say class for a person. What is a child of a person? Okay, person, a lesser person. Okay, we don't have lesser person. We can say infant. Let infant. But now this one creates a super class just like a person class, but we want it to take the values of the person class. So we use the extends keyword to pick the value, or rather the structure of the predefined class person. So use the extends keyword to inherit the property and methods of the person object. Yeah, so after that, you still have to pass the constructor, and the constructor will, just as in this class person, can also take all these objects. So the constructor can also take all that, and it should also return this same structure, because we also have to pass this dot. We have to use the this keyword to access, or rather to bind the constructor function to our class. So we still need the this keyword. Another thing that we are going to need, you see that here we have this calculate birth here. We can also reuse that calculate birth year in our infant class. But now for us to know that this is an extended class, or this is a child class, or for us to know that the child class is inheriting from another class, then all we need to do is we need to pass the super keyword. So super is also a keyword, take note of that, but you pass it in the constructor. So the super keyword in the constructor helps us to invoke the constructor of the parent class and pass, you can pass any arguments in that super keyword. So whatever arguments that were predefined in the parent class will be predefined inside the arguments that you pass in the super keyword. So the super keyword also ensures that there is correct initialization of whatever parameters were passed. Then another thing that the super keyword will help us is to access the properties from the person class. Yes, so there's also so first let us just create instances of the infant class. So we can have an infant called who is an infant. I can give Roberto to be an infant, and I say just the same way that you're creating the person class, you just say new infant. Then you see that here you can also pass in the values. So you say this infant, the name of the infant is Roberto, the age of this infant is 1, the height of the infant is 0.9, the weight of this infant is also 1. Yeah, so here we have an infant known as Roberto. So if you log this to the console, if you log this infant, this class Roberto to the console, then you're going to see the values of the infant. So when you run the script, you see that we have an infant, the name is Roberto, the age is 1, we see it has the height and the weight. Same way you can also call the calculate birth year of the infant, simply by saying Roberto dot calculate birth year. Yeah, this should be a function. Yeah, so if you run the script, you see that the infant was born in 2023, and the function correctly calculates the birth year. Yeah, so that is a simpler way of creating complex objects. For the super, you can also pass in all this data without using this keyword. So you can just copy all this and then you pass it in the super constructor. So you won't need to call this. You won't need to call this to all of them. So if you now run this script, you still see the exact same values are being printed on the console. So you see that typing in this dot, using the this dot to access all these parameters is also a bit hectic. So to reduce all that work, we pass in the parameters using the super keyword. So the super keyword will just map this constructor to itself, so that all you need to pass is the arguments. So here you see that we only pass the arguments, and the reaction is perfectly okay even from our terminal. So let me clear this. Then let me undo what I did here first. Also, let me comment out the super keyword so that you see how the super keyword is important. You now see that we have an error when you try accessing this dot name of the constructor name. Here it is very okay, you just say name then this dot name. But if you try and say name then this dot name in the class infant, which extends the person class, you experience an error because you have not you do not do correct binding of the constructor to the parent class or the super class to the child class or the sub class. So this is the importance of the super keyword. So it simplifies the task of passing in all this dot parameter, and instead you only need to pass in the name of the parameter. So you can also have an extra parameter, say healthy, and then here you now pass in because that does not belong to the super class. This is where you can now say this dot healthy, and you give it the argument healthy, the variable healthy. Then now when instantiating this infant class, you can now pass in the status of healthy. So you can say maybe for healthy you pass in true. So true will show that the infant is healthy. So if you clear the terminal and you run it again, you see now that the infant has the name, the age, the weight, the height, and the healthy is set to true. You also see that the born is 2023. So you see that instead of retyping all these things, you can just simply copy the constructor, and then into the constructor you add what you need, and you now anything that you add that was not in the superclass, you just use the this dot parameter to add it. And if at all you don't need the what don't we need, we don't need the height of the child, so you can just remove the height. If you remove it there, you also need to remove it here, and also from our height was 0.9, so we remove this 0.9. Yeah, so if you run this script, you see that oh, that is weight. Yeah, you see that the weight is undefined because it inherits all the properties of the person class. Yeah, so we've learned about inheritance. We've also seen that inheritance helps the child class to gain access, the infant class to gain access to the person class, and not just properties, but properties and methods. I also see that there's also something known as the prototype chain. So JavaScript uses prototype based inheritance model. Each object has an internal link to its prototype or its parent object. So this infant has an internal link to the person object because of prototype chaining. So when accessing a property or a method, JavaScript looks up the property chain. So when you try accessing this method, JavaScript will check where this method has been defined. If not, then it will come and if not, it will come and check the extents and then sees that this comes from the person class. Then it will come and look at the person class and see if it has the calculate path here. So it finds that this method belongs to the person class. So that is what we call the prototype chain. And for now, it may seem as a bit of too much explanation to do, but it's just a simple thing. We use this to check. We can just use this to check whether or not a property or a method exists in the parent or the child. So we can just use the dot has on property method. So first we have the Georges of the person, the Georges object of the person class, and we have the Roberto object of the infant class. So we're going to say we can use gen dot has on property, and this is a method that takes the ID or the key that you want to try and access. So here we're trying to check if gen has the property. Okay, it has all this name, weight. Okay, let's check first if it has weight. Then we're also going to check if it has this healthy property. So we'll check if it has on property healthy. And I'm just going to use the same things to also check the infant. To also check the infant class. So the infant class is we have an object there named Roberto. So I'll pass in Roberto to check the infant class. So if we run this script, you notice that nothing has been logged to the console. Let me just comment out this. Let me comment out all this logging to the console, so that we can have a clean console and we can understand the whole procedure of whatever is going on. Yeah, so now we should also log this to the console. Okay, and just do this quick way of selecting everything. and logging everything to the console. They will also need that and that. Then I'll just type console.log. Okay, so the whatever I've pressed for me to select all these elements, you just use Alt and then you tap the next place where you want that that cursor to be blinking. So you use Alt and you tap. So now if I run the script again, you see we have true, false, then true, true. So what does this mean? First, it checks if Jane has own property known as name. So here is where we have Jane. Jane has a new person and the person has a name property. So it returns true. The next thing it checks if Jane has a property healthy. It comes to Jane and it says that Jane is from the person class. Then it goes to the person class and see if person class has a property healthy and it's not there. So it returns false. That is now prototype chaining. It also checks if Roberto has own property name. It will come to where Roberto was defined or initialized or instantiated. It finds that it comes from the infant class. Then it checks the infant class if there is a name property, and it finds that there is a name property, and this is a super property. So it comes from the extends person, and it will also confirm that the extend person has a name, and it will output true. We'll also check that if Roberto has own property healthy, it will come and see and confirm that Roberto comes from the infant class, and the infant class has a own property known as healthy. So it will log true to the console. So the .has own property helps us in prototype chaining to determine or to discern whether or not the current object has the property that you're trying to match. So all you need to pass here is just the ID that you're trying to check. So lastly, we are going to also, why do we learn prototyping? Because prototyping is memory efficient. You see that methods are shared among instances via prototypes. This is around 10 lines of code to define a class person. But you see that we need only 8 lines of code to define a class infant with an extra property. So that is less lines of code, and we need to use less memory to define this class. So prototypes are memory efficient. We can also say that they are dynamic in nature because you can add or modify methods at runtime. So here you see that we have the calculate birth year, and it is being modified. You see that the calculate birth year is producing 2009, and when we run this again, it produces 2023. So that is modified during runtime. You also have flexibility because it is very easy to create complex inheritance hierarchies. Hierarchies is about the chain of the prototyping. So prototyping helps us to easily create those complex inheritance structures or hierarchies. So those are the benefits of prototyping. The next thing that we're going to look at, and I also believe the last thing on objects in year 6, we're going to look at the method overriding. When you say method overriding, we have used this term override severally, even in the previous place where we were using child user, and we were saying child here has the age of 10. So when you come and say child user dot user age and you pass in 1, then here we override the value of the age property from 10 and give it a new value of 1. But this is on properties. Now we want to look at method overriding. So for the methods, here we have a method calculate year of birth in our person class, and we also have calculate year of birth in our let me just uncomment it. We also have calculate year of birth in our in our child class. So now imagine that we have that person class with that calculate birth year method, and we want to create the infant class such that the calculate birth year overrides the calculate year of the parent class. So that is like we are customizing this calculate birth year method. So what you can do here, you can say that you can just add here something like infant born in, or okay, instead we're calculating the birth year. Yeah, you can just say infant born in that, and then this other one says that parent born in that, such that if you call the calculate birth year on the parent, and you call the calculate birth year on the child. Let's just comment this dot has on property for now. So if you run the console, you're going to see that parent was born in 2003, infant was born in 2023. You see that these two have different strings, and actually different you can say it brings different results, but you're calling the same method. So this is calculate year of birth. This is also calculate year of birth, but both bring different results. This one says parent is born in 2009, and this one says infant is born in 2023. And you can even say infant is born in no, infant is, and then you pass in just the age. So you can even change the computation. And you see that here, you see that parent was born in 2009, and you see that infant is 1. We can say 1 here. So clear. And then rerun the script. See that calculate birth year returns parent was born in 2009. But for the infant, when you call calculate birth year, it returns infant is 1 year. So you see that the same method is bringing different results. So that is what we call method overriding. Method overriding helps us to take control of our methods in child classes. So that's it for object-oriented programming, or rather the use of class keyword, the use of inheritance. So you must note that inheritance depends on the extends keyword. The extends keyword. We also have the super keyword. So we have these two keywords that are very important when dealing with inheritance. Method overriding, you must note that it uses the exact same method name, but to return different results. So that's it for today's video. I hope you now have a gist or a basic understanding of object-oriented programming in JavaScript. Still, you can access the resources, the README with notes, the GitHub repository that is provided in the link below. Either way, you can just visit github.com, then search for Georges Roberto, and that way you're going to get a Learn Web Development repository. With that, you can find these codes that I'm currently writing on this page. So that's it for today's video. I hope you liked it. If you do, just hit the like button. Share this video widely to reach out other people who you think it may be of help. Also, you can leave a comment down in the comment section. Tell us more about your experience in this video and in the whole course as a whole. If you've reached this point, I would wish to send much thanks to you for promoting us, for investing your time in us. Have a happy coding week.